So today we're going to talk about kinematic equations and how to solve those. These type of problems are going to be a little bit different than the average velocity problems. The average velocity was equal to delta d over t, your displacement divided by your time. You only had three variables and you were given two of them and asked to solve for a third. But with kinematic equations, we're going to introduce acceleration into these formulas. And so we're going to have a formula that has more variables than just velocity and displacement and time. So now we're going to have acceleration added to that. And we have what's called the big four equations we'll talk about in just a minute. But first, these are some problem solving strategies for working these type of problems. Number one, read the problem carefully. Identify the known values of 3 of the 5. That's what our givens are. What we're saying, our guess methods are givens. Write down the known values, relate the values to the symbols. Number two, identify the unknown variable, write it. Number three, now that you have 4 variable symbols with known values and 1 of unknown value, find the kinematic equation that contains these 4 variables. Write the equation down. Number 4 is substitute known values to this equation. 5 is perform algebra and calculations to solve for the unknown variable. So that's just our guess method, our givens, our unknown, our equation, substitute, and solve. We're going to follow that, work these problems to make sure we don't make any mistakes. Now, these are going to be word problems, but the units tell us what we are, what it is. If it's in meters, that's the displacement. If it's in meters per second, that's the velocity. If it's time, it's going to be in seconds or hours. Or if it's acceleration, it's going to be in meters per second squared. We have to know those units. So to look at the equations now that we're going to be using, you will need to write these down in your notebook, and you don't have to memorize them. I'll let you use these on our bell ringers and everyday work and on our tests. Our 9 weeks exam will cover this material, and average velocity, everything from the Unit 1 test to the 9 weeks test, but it'll be pretty much covering Unit 2. So what these different things shows, D's for displacement, A's for acceleration, T for time, VO is original velocity. Now, some people will use, instead of VO, they'll use VI, and that's fine if you want to use that to stand for initial velocity. And I'm going to embed some other videos of YouTube, people off YouTube teaching this, just in case you need it after today, and they might use VI instead of VO, or they might use X for displacement instead of D. It doesn't matter. I like to use the ones that are on here. Sometimes I'll use VI instead of VO, which is actually V naught is how it's pronounced. It's with a little VO there. All right, so we will read a problem and we'll decide which one of these equations will be best used. Now, sometimes you can pick between two equations. You'll have enough variables, the problem will give you enough information to where you can pick between, 2 out of the 4 might work, and you just pick whichever one that works. They'll give you the same answer though, so it won't matter in that case, but most of the time, 90% of the time, only one of these equations will work. So you'll have to figure out which one. Now, this third one, I would rewrite that down in your notebook, because it's the way it's written here. You really need parentheses around this part here, because if you take V naught plus VF and then you divide it by and you say 2 times T, it's going to give you the wrong answer. You have to divide by 2 and then multiply by T. So I would rewrite that as this: V0 plus VF divided by 2, and then multiplied by time. Alright, so when we work these problems, we also want our displacement in meters. Our units have to match up. Displacement in meters, we want velocity in meters per second. We want acceleration in meters per second squared. We want time in seconds. So if anything's not in those units, we have to change them before we start the problem. So if we look at the first problem, and you can use the notes that are attached with this lesson. Or you can, I would write these example problems down in your notebook or just refer back to that handout. Now we want to read the problem carefully, and I'd like to go through and underline what's the information that it's giving me. So it's starting from rest, the car accelerates at 6.52 meters per second squared. That's an acceleration because it's in meters per second squared for 3.80 seconds. It also tells me it starts from rest. That's important. Determine the distance traveled, and this should say displacement, but distance and displacement a lot of times are the same thing by the car during its time. So what I want to do is write down all of those variables. I have final velocity, I have initial or V0, and say I'm not consistent with what I use, it really doesn't matter. Another thing is acceleration, displacement, and time. Those are the 5 variables that are in all these equations. And then I'm going to start writing down what the problem gives me. It says starting from rest, so that means I'm going 0 meters per second in the beginning, and accelerate for 6.52 meters per second squared for 3.80 seconds. Determine the distance traveled. So this is my question mark, the distance here, and it's going to be in meters. So it doesn't give me final velocity. It doesn't ask me to solve for final velocity, so I can just mark through that in this example right here. Now I need to look and see what equation up here has these 3 things in it that I could use. All right, I need the equation cannot have final velocity in it or it won't work. So this one's not going to work. This one's not going to work. This one's not going to work. So only the one at the top, it's the only one I can use. So I'm going to write that down. And then I'm going to start putting in my numbers. So it would be d equals, initial velocity is 0 times t, which is 3.80. And I could have just not wrote that, knowing it's going to equal 0, plus 1/2. Acceleration is 6.52 times my time squared, 3.80. Okay, so that equals, d equals 0 plus 47.0744. I would not round into the very end of the problem. And then once we round to the very end of the problem, we can round to 2 decimal places. That's my rule. Instead of going by significant figures, I'd like for you to round to 2 decimal places. That way we're all, consistent. We're just using algebra in these problems. We're plugging in numbers for symbols and using algebra, and you've all been doing that for a few years now. So what my answer would be is d equals 47.07 meters, since I'm talking about displacement or distance. Now if you get something very close to that, I wouldn't count it wrong. If you have something like 47.2 or 46.8, that's close enough. It's kind of a lot. It depends on if you round during the problem or not. Okay, our next example, like I said, we're going to go ahead and write down all 5 variables. We have final velocity, initial velocity, acceleration, displacement, and time. Okay, a bobsled moving at 32 meters per second. decelerates to 22 meters per second at a rate of 4.8 meters per second squared. Determine the distance. Again, that's distance or displacement. A lot of times they mean the same thing, unless you're sometimes your displacement is going to be less because it's from where you start to where you end up. But it's already a problem moving at also moving at 32 meters per second. That's initial velocity. A lot of times if it tells you something's at rest, that's always initial velocity of 0. If it tells you something comes to a stop, that would be a final velocity of 0. In this case, it's 32 meters per second. Decelerates to 22 meters per second. At a rate of 4.8 meters per second squared. However, since it's decelerating, that means our acceleration is going to be negative. If you don't put it in as negative, it's probably going to give you the wrong answer. And that's meters per second squared. Then we're going to determine the distance. That's my unknown. Put a question mark there. And t is not mentioned in this problem or asked to solve for it, so we can just do away with it. Now we want to look up here at what equation can we use. Anything with time we can go ahead and mark out. So this one we marked out, this one, and the top one. The only one we can use is the second one there. So I'm going to write that down. VF squared equals V0 squared plus 2AD. I'm going to plug my numbers in. So that's going to be 22 squared equals 32 squared plus times D, and I'm solving for D. Okay, so when I do the math, I get 484 equals 1024 plus negative 9.6 D. So next I need to subtract both sides by 1024. Trying to get the D by itself. So that's going to equal negative 540 equals negative 9.6 D. When I get to that, divide both sides by negative 9.6. And that's going to give me D being equal to 377.33, and that's going to be in meters. Alright, now one thing is so far our units have matched up what we've needed. We've not been given anything in kilometers per hour. If we are given, if anything is going to be different, a lot of times it's going to be your velocities. So just know that if we're going from, if we are given kilometers per hour, we need meters per second. So you divide by 3.6. Memorize that. You'll have to use that. Make sure you always read these problems carefully. If you're given a displacement in kilometers, you need it in meters. Don't get that mixed up with the kilometers per hour to meters per second. It's different. This we would use the King Henry diet by drinking chocolate milk, which would be pretty much moving your decimal 3 places to the right or multiplying by 1,000. And sometimes you'll be given time in, say, hours, and you want seconds. You can multiply by 3,600. Or if you're given minutes and you want seconds, you'd multiply it by 60. But always read the problem carefully to determine if you need to change something before we begin. And I think this last exact problem is the same way. It doesn't have anything we need to change. We just make sure when you start working these problems that you do that. And I have the answers provided for you in the worksheets in the practice, so you can make sure you know you're doing it right, and then the next day you'll be able to check your work with how the problem's worked out. And if you need me to make more videos, just message me on Schoology and I'll do that. But I'm going to embed some YouTube videos of people working problems just like these for you to go by if you need that extra help. Some of you probably won't after just seeing me work 3 problems. Right, so this last problem, in a hurry, is traveling at 6.8 meters per second, or traveling at 6.8 meters per second, excuse me, which realizes she is late for an appointment. She accelerates at 4.5 meters per second squared for 3.2 seconds. What was her final velocity? Alright, so I'm going to write down all 5 of my variables. Final velocity, initial velocity, acceleration, displacement, and time. So she's traveling at 6.8 meters per second, and that's the beginning. And remember, if somebody starts from rest, that's 0 meters per second for initial velocity. If they are coming to a stop, their final velocity would be 0. But you'll run into a lot of problems like that. And she accelerates at 4.5 meters per second squared, 3.2 seconds. What is her final velocity? Oh, I wrote that down wrong, and originally that was an initial velocity of 6.8 meters per second. And my units all match up. Got meters per second squared, 3.2 seconds. So my final velocity is going to be in meters per second. All my units are good. I don't have to change any before I begin. It doesn't say anything about displacement or distance, and doesn't ask for it. So I can mark through that. So I can look, anything with displacement up here, I can mark through because it's not part of the problem and it's not asking me. It's not my unknown or my givens. So I can go through this first one, I can mark through. The second one I can't use. The third one I can't use. The only one I can use is that, the bottom one. Which tells me that my final velocity is equal to initial velocity plus acceleration times time. Then next I'm going to substitute and solve. My answer is going to be 21.2, and it's going to be in meters per second since it's velocity. And then make sure you put a box around your answer. Should have actually been 21.20 if I'm going 2 decimal places. And that's how you do these problems. Now the ones you work might be, most of them are going to be just as easy. Might be 1 or 2 that so you might have to convert from kilometers per hour before you start the problem, and it might just be a little bit more difficult, but I think you'll be able to do that. Again, let me know if you need me to make some more videos for you if you're having trouble, and refer to the ones I'm going to embed with the lessons this whole week where you'll learn how to do this. I don't think you'll have any problems if you'll put the effort in to work all the problems. All right, good luck.